Okay, well, I'd like to show you the setup for the second harmonic generation lab now. So let's see. Right now, the laser beam, which is on, is proceeding down to here. This is our partially reflective mirror. Part of the beam is reflected and part is transmitted. The part that's transmitted ends up here at a beam block. Part that's reflected goes through a polarization rotator, and then right now it's going to a power meter. But if I remove the power meter, it will go to a lens, which will focus it onto a BBO crystal. Then the light will go through a glass filter that blocks red light, the laser light, and then it will go to a screen. Okay? There's a spectrometer that's focused on, that's viewing the screen. So we can measure the spectrum of the radiation that's produced. Here, let's describe how this works. So right now, there's a power meter, which is viewing the beam. We're on the 1 watt scale on the power meter. If I rotate the mirror, it's a variable mirror, so I can rotate it and change the amount of power that goes to the optics. So now we're at 900 milliwatts. Now we're at about 1 watt. So in this setup, the maximum power is about 1 watt. Here, let's go back down to a low power. Maybe, I don't know, how about 40 milliwatts, about here. By the way, you view this by looking at the needle and position your head so that you can see the reflection of the needle is right behind the needle. That's to eliminate what's called parallax error. And then if I remove this, we might get to see second harmonic generation. Now, I'll do that in a second, although I'm not going to show you the second harmonic generation yet. We'll wait for the lab. I want to show you a couple other things. First of all, we'd really like the crystal to be at the exact position of the focus of this lens. We can move the crystal back and forth with this adjustable stage, okay? And so if we do that while we monitor second harmonic power, we can optimize. Another thing we can adjust is the angle of rotation, the polarization angle of the beam with this polarization rotator. Okay, very good. I'm going to carefully put the BBO crystal well out of range and move this aside, okay? Now, finally, to do a power measurement for the second harmonic, first I'd like to measure the power of the primary beam, and then we'll move the power meter over here and measure the power of the second harmonic. Of course, right now it's very low, so we're not really measuring anything, okay? I would like to show you something though, while we're talking. I'd like to show you something about how to make sensitive measurements, okay, with this power meter. So just before I do that, I want to show you one thing. If I turn the, leaving the selector here, if I remove the glass filter, you'll see actually almost all of the radiation reaching the power meter, all of the laser light, okay? But that's red laser light, we're not interested in it. Let's go back to here, okay? Now, let's imagine that we have very little laser light. I'm going to reduce this as much as I can. There we are. To accurately measure the power now, I need to reduce the scale on the power meter. So now it's 300 milliwatt scale, now 100 milliwatt scale, 30 milliwatt scale, actually more than 30 milliwatts. Can I get it down onto that scale? Apparently not. Okay, there we are. But 30 milliwatts is actually the lowest scale that we can operate this on. Oh, there we go. 100 milliwatt scale. On the 100 milliwatt scale, this is about 45 milliwatts. Very good. Now, at these low scales, we have to watch out for something. What we have to watch out for is that the meter might not be zeroed. The meter is a thermal power meter, and it measures the temperature change of the sensor when the laser beam hits it. A system like that will easily become offset by a little bit due to fluctuations in the environment. If I block the laser beam, you'll see that the needle goes not quite to zero, okay? I can adjust the zero with this knob until it is accurately zeroed, and then I can do a measurement. Something else to be aware of, if I block the laser beam, and now if I put my hand here, can you see it's measuring the thermal radiation from my hand, which is not negligible. So you have to make sure that your body parts are not in the field of view of the camera when you do this. Anyway, it should work pretty well. So that's how this measurement works. The adjustments are the rotating the mirror, which adjusts the power. Okay. Oops. Adjusting the position of the BBO crystal by rotating this knob, and adjusting the polarization angle of the light, which will also adjust the efficiency of second harmonic generation. Great. Let's stop here.